Alright, we have the dissolution of an insoluble salt, which is aided by the formation of this complex ion. So we know that what we have is a dependent equilibria. So first we have to dissolve the soluble salt. Okay, when this salt is insoluble, but we know a tiny bit dissolves, and whatever dissolves dissociates. Equilibrium constant here is KSP. And now, once this Ag plus has been released in solution, it reacts with the thiosulfate to yield our complex. Alright, our thiosulfate, we know we require 2 of them. We can tell from the formula of the complex ion. Alright, so our net reaction is going to be the sum of these 2 reactions. So Ag is released, consumed. We have AgI, solid, in our net reaction, reacting with the thiosulfate to yield our complex ion. And iodide ion in the solution. Okay, so we have these 2 equilibrium constants of the associated reactions. They sum to some net reaction. So we know K net is going to be the product of the 2 associated Ks. So this is KSP times KF. And once we do that, we find this product is numerically equal to 0.0014. Alright, so now we can go on and write our equilibrium constant expression. K net, we need room for our ice table, excuse me. K net is our complex times the iodide ion divided by the concentration of our ligand squared. Okay, our insoluble salt doesn't appear in their equilibrium constant because it's a solid. Alright, so now we have to go back and complete our ice table so that we know what the equilibrium quantities are here. So initial change equilibrium. This starts at 0.500. We're going to take away 2x moles of the thiosulfate for every mole of this that forms. So equilibrium, initial plus change, and we can substitute these values in. Okay, 0.5 minus 2x is squared. I'll write it this way to make it easy to see that we have a perfect square here. Okay, if we take the square root of each side, we would find the square root of 0.0014 is equal to x over 0.5 minus 2x. Cross multiply. So, let's see, that square root is 0.0374 is equal to x over 0.5 minus 2x. So we have 0.0374 multiplied by this is going to equal x. So we have to use a distributive property to multiply this times this minus this times this. So this is 0.0187 minus 0.0748 times x is equal to x. Now we collect the like terms, which means that all values of x need to be on one side. And 0.0187 was equal to 1x plus 0.0748x. And finally, x is equal to 0.0174. Now that we have a value of x, we can go back and answer the question. Okay, the question is asking for the molar solubility. So the molar solubility here is x. Okay, S and x are essentially the same thing. And we have our answer with 2 sig figs.